Hey guys, here's a video walking you through number 12 from that first worksheet where people were having some trouble. So let's go through it step by step, see how it goes. First things first, we got a rectangular box with an open top. So I don't know, rectangular box, open top, and the volume it says is 10 cubic meters. So that's all I know so far. The length of its base is twice the width. So it doesn't really matter which one you want to be what. Let's just call this the base and this the width. So if this is the width, this one is twice as big. Okay, and obviously I didn't draw it to scale, but it doesn't really matter which one you pick as long as one of them is twice as big as the other, since you could rotate the box. The height we do not know. We have no idea what its relationship is, so that's just h. And then it gives us some values for the cost. So it's a little bit different than the other ones we've done, where now we have to deal with cost. So it's $10 per square meter for the base. So the base cost is $10 per square meter. And then the sides, excuse me, is $6. So sides cost is $6 per square meter. So at some point, we're going to have to find a formula that deals with cost, since it says find the cost of materials for the cheapest such container. Well, materials, that translates in my mind to surface area, but then they want us to use cost. So first thing I probably want to do is come up with a formula for surface area and then figure out how the cost connects to that. So surface area, well, I've got a bottom of this thing, so that's 2w squared, plus I have the front, which is 2w times h, plus another 2w times h in the back, so the front and the back, that's 2 of the 2w's times h. I've got a right side here, which is w times h, and a left side here, which is another w times h. So I have 2 of these w times h's. So that's the total surface area of this box. Again, no top, so I don't have to worry about the other 2w squared. Let's clean that up first. The 2w squared plus 4wh's and 2wh's, and there you go. Problem is, that's not what we're trying to minimize. We're trying to minimize the actual cost. So I need a formula for cost. Well, the cost is $10 per square meter. So that's $10 times the 2w squared. That's the base right here. Base, and these are the sides. And then $6 for the sides. So plus 6 times 6wh. Clean that up for a second. We got 20w squared plus 36wh. Now I've got my formula to minimize. The problem is there's more than one variable, which we never like to have if we can avoid it. Luckily, they gave us the volume. Well, the volume is 10 cubic meters. Well, the volume is also 2w times h. So 10 equals 2w squared h. So h equals 5 over w squared. Oops. Cut off there a little bit. I can take that h and actually plug it into my cost formula. And then my cost formula is going to only have, in terms of w now. So let's do that next. So the cost is going to be 20w squared plus 36w times 5 over w squared. Clean that up one more time. And I think we're almost home free. 36.5, that's 180 over w. And I think we're ready to differentiate and find the critical values. Excuse me. So C prime is 40w minus 180 over w squared. Remember, this is probably easier to refer to or think of it as that, 180w to the negative 1. This way you don't have to worry about a quotient rule, although both of them will get you the same result. We need to go ahead and find the critical value for this. So this is really only going to give us a critical value when we're undefined or 0. Well, w being 0 is not going to give us anything of value since the width can't be 0. So let's just worry about what's going to happen when I combine these fractions and look at the numerator. So C prime is going to be 40w squared, w cubed minus 180 over w squared. And I think I'm getting a little cut off here. There we go. So again, just let me explain again what I just did. So I got a common denominator, w squared. So I multiplied by w squared over w squared. That gave me 40w cubed minus 180 all over w squared. So when is 40w cubed equal to 180? 40w cubed equals 180. when W cubed equals 9/2. So W would be the cubed root of 9/2. So there's our width. Well, if we have our width and we have our cost formula, which the simplified version is, where did I have it? Here it is, sorry. Here's the simplified version for cost right here. I can plug W in to here and figure out what the cost is. So let's do that here. Cost is 20 cube root of 9/2 squared plus 180 over W, which is the cube root of 9/2, which need a calculator to kind of help me with, I think, on this one. So I'm going to go ahead and plug that into the calculator and see what we get. 20. I need the square cube root of 9/2 squared, so that's 9/2 to the 2/3. So times 9/2, which is 4.5 to the 2/3. There's the first part, plus 180 divided by just the cube root of 9/2. So 4.5 to the 2/3. And I get 120, not 2/3, I'm sorry. That should just be 1/3, excuse me. Let me fix that. The other one was 2/3. This one is just the cube root of 9/2. This one's the cube root of 9/2 squared. So this should just be 1/3, which is 163.54. 163.54, double check, yeah, 54 is the minimum cost for a box with an open top that charges you $10 per square meter for the base and $6 per square meter for the sides. That's how you would solve one like that. So take a look, feel free to rewatch, ask me any questions if you still have any, and I look forward to hearing from you guys soon. See ya.